All right, so you should have these examples. Hopefully you have it with your stuff. If not, you can just write them down and practice them. So if you notice this, I have 3 terms inside of here that are being multiplied together. I have the 25, I have the a to the 4th, and I have the b to the 9th. So last week's homework, these all worked out evenly. The problem with the b to the 9th is that this is a square root, and I can't split 9 up into equal pieces of 2. So what you have to do is you have to rewrite this, and I don't care what order you do this in. I'm just going to leave the 25. The a to the 4th is fine. But what's the biggest thing I could split this up into? Couldn't I say b to the 8th? Because 2 does go into that. And you don't really have to put b to the 1, but that's what it would be. So that still makes b to the 9th. So I rewrote it, and if I look, all 3 of these things now are perfect squares. So this would be 5a squared, b to the 4th, and then square root of b. That would be my answer. I do need to check even and even coming out odd, and you always look from the beginning. So this was an even and this was an even, but when you did the answer, it didn't come out odd. So you still do have to check what we learned on Friday about even and even coming out odd. Okay? So I would like you to pause and do this problem, and then I'll work it. Every time I say pause, please just pause and try it, because you can just watch me do every problem, but that's not going to help you be able to come back and take the test. So pause and then try it, and then if you don't match mine and you don't understand it, then you can email me, I did not understand example 10. Does that make sense? But if I just work every problem, you're probably going to not do as well as you'd like. So if I look at this, 125 is a perfect cube, 3 goes into 30, but 3 does not go into 20. So the easiest way to do this is to rewrite it so that the closest thing that 3 goes into, that's below 20. So wouldn't that be to the 18th? Okay. So I rewrote p to the 20th as p to the 18th, p squared. So now I look, and all 3 things of these are perfect cubes. The cube root of 125 is 5. The cube root of m to the 30th is m to the 10th. The cube root of p to the 18th is p to the 6th. But I cannot do anything with p squared, so this is my final answer. Okay, now I don't even have to worry about even and even because my original problem, this was odd. So I don't even have to worry about absolute values. Okay, so pause and try this one. All right, if I work it out, the 16 is okay. And like I said, some kids simplify that. The one that's not okay, and this is a squared, so I'd rewrite this as y to the 10th times y. All 3 of these are perfect squares, so that would become 4x squared, y to the 5th, root y. Now, this is where this gets confusing, so please listen very carefully. This was even, this was even, and this was not even. So I do not have to put absolute values on it. You only put absolute values if in the original problem, it was even and even coming out odd. So the only one I had to worry about, I didn't have to worry about an absolute value on the y, but I did have to worry about an absolute value on the x because those were even and even. But if I look at my answer, it came out even, so I don't need absolute values. You only absolute value the things that have even and even in the original problem. Okay, so try this guy, pause. All right, so 625, and that's not one I'm asking to memorize, but it is a perfect 4th. It's 5. 4 goes into 28, so that one's good, but I need to rewrite this one. So I'm going to have the 4th root of 625, b to the 28th, k to the 20th times k to the 3rd. Because that splits that up, and now it does go in. So all of those are perfect 4ths. So this would be 5, b to the 7th, k to the 5th, and then the 4th root of k cubed. Okay, now I need to look at the original problem. Okay, I have an even and an even. The next one, so the only one I need to worry about putting inside an absolute value is the B, because this was even and even. And did it come out odd? Yes. So this has to go in absolute value. So my answer would be 5, B to the 7th, K to the 5th, and then the 4th root of K to the 3rd. So this obviously is a harder example. There's not going to be a ton of these that have absolute values. So if that's the part you miss, you're missing a point or two on the test. But remember, if it starts as an even and even, then you have to do that. All right, this is where this gets really confusing. And so I need you to watch this first example. So I would split it up. We've done these. Y to the 8th over the square root of x to the 7th. There are two ways to do these problems. And if you look in the textbook, they do it one way and I teach it another. So I'm going to teach you this right here is Mrs. Williams's way, okay? And I like this way because you're going to see in a minute, it makes it easier in the long run. So I can't have radicals in the denominator, so I need to think of a way that's going to make this a perfect square. So if I multiplied it just by the square root of x, wouldn't that give me the square root of x to the 8th? Just adding 1. So wouldn't that just be x to the 4th? And I'm done on the bottom. I just took care of the bottom. So if I multiply the bottom by the square root of x, then I have to do the same thing on the top. Well, what is y to the 8th square rooted? Wouldn't that be y to the 4th and then the square root of x? I can't simplify that because it's inside to outside. Sorry, I don't know why I wrote 3. So this is y to the 4th square root of x. And this is my answer. I'm done. But the textbook, so those of you, I mean, there's a few of you gone. If you like to look at the textbook examples, I don't care which way you do this, but I want you to understand what the textbook is doing. The textbook, their way is easier on the front, but harder at the end. So the textbook does this. If the bottom is the square root of x to the 7th, then they multiply by whatever the bottom is. So then you end up with the square root of x to the 14th on the bottom, which becomes x to the 7th. And if you're like, that's not the same answer. Well, it's not. I'm not done yet. That's the reason why I'm not a fan of the textbook one, but you can do it that way. So y to the 8th becomes y to the 4th, and then I would rewrite this as x to the 6th times x. So then when I square root x to the 6th, I end up getting x to the 3rd root x. Well, now look at these. I have an x to the 3rd on the top and an x to the 7th on the bottom, so won't 3 cancel? And I get y to the 4th root x over x to the 4th. So does the textbook and Miss Williams get the same exact answer? Yes, but the textbook way actually takes more steps, but you don't have to think about it. You just multiply by whatever's on the bottom, okay? So I would like you to try this one. No, I would not. Do not try this one. Stop. Don't try this one. We need to look at this. So here is the reason why I really don't like the textbook way. Oops, I'm going to use orange because that's the Miss Williams way, right? So I have the cube root of 2 over the cube root of 9x. So I need to make the number a perfect cube. So Mrs. Williams' way is harder because you have to think about it at the beginning, but once you get it thought about, you don't have to do extra math. So I need a number that's a perfect cube, and so that would be 27. So wouldn't I times by 3x squared? Because if I times, and you have to think about this, I need to make it a perfect cube, so that would be 27x cubed, and then that is a perfect cube, so wouldn't I get 3x? So if I times by that on the top, or on the bottom, then I'm going to do the same thing on the top. So I would have the cube root of 6x squared. Well, nothing goes into 6 that's a perfect square, or cube. If I write my perfect cubes, 1 cube is 1, 2 cubed is 8. 8 doesn't go in there. So that's simplified. So I am done. I had to think at the beginning, but those x's don't cancel because one's inside the cube root. The book way, I need a calculator. This is going to be difficult, okay? So if it's a cube root, if I times by the cube root of 9x, that gives me 81x squared. Well, that's not a perfect cube. 81 isn't a perfect cube. So you actually have to, the book way, if you look in the book, whatever it is, if it's a cube root, then you do 2 other times. So you end up getting the cube root of 729x cubed. So that would become 9x, okay? So then you have to do the same thing on the top. 9x, the cube root of 9x. So that's 81 times 2 is 162x squared. So now I need to think about a perfect cube that goes into 162. Oh my gosh. Sorry, I'm trying to get my calculator open and it's being dumb. All right, so, because I can't do this in my head, so I'm going to do 162 divided by 8, because that's a perfect cube. Does not go in. So I'm going to do 162 divided by 27. Oh, it goes in 6 times. So I'm going to rewrite 162 as 27 times 6 times x squared. Well, the cube root of 27 is 3. And if I look, 3 would cancel with 9. So I would get the cube root of 6x squared over 3x, which is the same answer that Mrs. Williams got, but it took me much less steps. Okay, so try this one. Pause and try it. Do it my way, do it the other way, I don't care. So if I do pause and then I'm going over it. So if I do it my way, this would be x cubed over the square root of y to the 7th. So I would times by the square root of y, because that would give me the square root of y to the 8th, which is a perfect square, which would give me y to the 4th. So that means on the top, I would have x cubed times y. Well, x cubed can be rewritten as x squared times x times y. So that would end up being the square root of x squared would end up being x square root of xy over y to the 4th. So I'm done. That's if you do it the Miss Williams way. If you do it the textbook way, you're going to do the square root of x cubed over the square root of y to the 7th. The nice thing about the textbook way is you don't have to think about it. Whatever's on the bottom is what you times by. So this is going to be the square root of y to the 14th, which comes out y to the 7th. And on the top, you're going to have x to the 3rd, y to the 7th. So I can rewrite that as x squared times x y to the 6th times y. So that ends up being the square root of x squared is x. The square root of y to the 6th, oops, edit undo, I didn't want to erase that. The square root of y to the 6th is y to the 3rd. And then I still have the x and the y left in there. And now I look out in front, these still can cancel. So I have x square root of xy over y to the 4th. So I get the same exact answer. I don't really care what you end up doing. I do get the exact same answer, but one of those methods should make sense to you, orange or blue. Okay, so I would like you to try this one. Pause and try it. Okay, if I do it the Miss Williams way, I have the cube root of 8. Well, that's 2. I'm going to simplify that. And then this would be the cube root of 3y squared. So I need to figure out what I would multiply by so that it's a perfect cube. So 3 times 9 is 27, and that's a perfect cube. Y squared times y would be y cubed. And so when I multiply that, that is a perfect cube. So I would just get 3y. So my method is harder because you have to think about what to make it. But once you figure it out, you're pretty much done. Okay, nothing goes into 9. That's a perfect cube. Nothing. And so I'm basically going to, my answer is 2 cube root of 9y. That's my answer. Okay, if you do it the textbook way, then I'm going to cube root 8. The cube root of 8 is 2. Whether you're doing it the textbook way or the Miss Williams way, I would cube root that 8. So the cube root of 8 is 2 over the cube root of 3y squared. So the textbook way just says whatever the bottom is, you're going to do that until you get a perfect cube. So if it's a cube root, you're going to have to do it twice. If If it's a fourth, you're going to have to do it 3 times. It's just kind of a pain. So this ends up being the cube root of 27, y 246, y to the 6th. So that ends up being, the cube root of 27 is 3. The cube root of y to the 6th is y squared, right? So then I do the same thing here, and I still have my calculator on, so you don't have to wait on me for that. So this ends up being 2 cube root of 9y to the 4th. Well, I can rewrite 9 to the 4th, y to the 3rd times y, right? So the cube root of y to the 3rd, that is a perfect cube. So I would end up with, hold on, that's a little bit of writing here, cube root, oh, the y would come out in front, 9y over 3y squared. So then the y in the front and the y squared would cancel, and I end up getting 2 cube root of 9y over 3y, because one of those cancels. So you end up getting the same answer, but the book method is more steps, which is more confusing. Okay, so in the book it tells you that the index, to be simplified, then your index has to be as small as possible. There can be no other factors that are in there. The radicand can have no fractions, and the radicals cannot be in the denominator. So those are things that are important. So if I look at this, I can multiply inside to inside, so that's 5. And then, outside to outside, which is 5. Inside to inside, I'm going to use my calculator because my brain is fried today. Times 10 is 1,000 a cubed. Well, 1,000 is a perfect cube. 10 times 10 times 10 is 1,000. So this will come out because it's a perfect cube. So that comes out and it becomes a 10. And 5 times 10 is 50. And a cubed is a perfect cube. I forgot my cube on this. Sorry. A cubed is a perfect cube. It would come out and be 50a. Okay, so you try this one. It's just a practice. Write it down and try it. Pause, try it. So I'm multiplying outside to outside, and I get 6. Inside to inside, 16 times 4 is 64, a cubed. So 64 is a perfect cube. That's 4. So when you take that out, 4 times 6 is 24. A cubed is a perfect cube, so that comes out and becomes 24a. That's my answer. Okay, on this one, you can only add together like terms. So 45, 80, and 20 are not like terms, but 45 is 9 times 5. And so can't I say the 9 comes out front, that's a 3. 3 times 3 is 9, so it's 9 root 5. 80 is 16 times 5. So the 16 comes out in front, and there's a 5 there. 5 times 4 is 20, so that's 20 root 5. And then 20 is 4 times 5, and so the 4 comes out in front, and you already have 2 there, so it's going to be plus 8 root 5. Now they are like terms, so 9 minus 20 is a negative 11, plus 8. Negative 11 plus 8 is a negative 3, so my answer is a negative 3 root 5. So if my radicals are the same, I can combine them. Okay, so try this one. Pause and try it. 75, these are not the same, so I'm going to see if I can rewrite them. 75 is 25 times 3. The cube root of 25 is 5 times 3 is, so I'd have 15 root 3. 48 is 16 times 3, which this is a perfect square, so 4 times 2 is 8 root 3. Plus, I'm going to put a 1 here because there is one of those. So now these are like terms, so 15 minus 8 is 7, 7 plus 1. So my answer is 8 root 3. Okay, so we've done foiling. So now I'm foiling. Outside to outside is 6 root 3. And then this would be minus 2 root 9. This would be plus 3 root 5. And this would be minus 3 root 15. So if I look at this, I can't rewrite 3. 9 is 3. So I would have 6 root 3 minus 6, because 3 times 2 is 6. I can't rewrite 5. And 15 doesn't have a perfect square that goes into it. So if I look at my insides, none of them are the same and none of them can be rewritten. So this is my answer. That's as simplified as I can get. So try this one. Pause and try. So I would have 10 root 5, and then minus 2 root 35, and then plus 20 root 6, and then finally I would have minus 4 root 42. Nothing goes into 5, nothing goes into 35, nothing goes into 6, nothing that's a perfect square goes into 42. So this is my final answer. And order doesn't really matter. All right, so in the triangle below, showing the height, the ratio of the base is x over this. They want you to conjugate to rationalize the denominator. So really the story problem on tonight's homework is not even asking you to really do any math. They just want you to get rid of the denominator. So I would multiply by x root 3 minus x. Because if I do that, I end up, if I FOIL that bottom, I would end up with x times root 9, which that becomes 3, minus x squared root 3, plus x squared root 3, minus x squared. So these middle terms would cancel, and so I would end up with 9, the square root of 9 is 3, so I'd end up with 3x minus x squared. So now if that's what I multiply the bottom by, that's what I would multiply the top by. So that would be x squared root 3 minus x squared, right? So I'd have x squared root 3 minus x squared. I would take off for this answer because on the top, just change so you can see it, I can take out an x squared. So that would leave me with a root 3 minus 1. And on the bottom, I can take out an x. Oh, wait, that would be an x squared. Good morning to me. Because x, if I multiply, my first term was wrong. It should be x squared root 9. So this is an x squared. So on the bottom, I can take out an x squared. And that leaves me with 3 minus 1, right? And 3 minus 1 is 2. So my x squareds from top to bottom would cancel. And so on the top, I would have root 3 minus 1. I can't combine those over 2. And that would be my answer.